Okay, we're going to do some roots, simplifying radicals. You know how to simplify square roots, so now we're going to expand on that and learn how to do other roots, like cubic root or a fourth root, something like that. So this is just some notation. The little house guy, that's not working out. The black symbol here, that's called the radical. The number underneath is called the radicand. And then the number that's in front here, that's called an index. And if there's not one written, it's an understood 2. But if it's anything else, there'll be a number there. So we always are aware that some numbers we're going to have 2 square roots. You're going to have the positive and the negative version. So whenever you're given a radical without a sign in front of it, it's asking for the principal root. Principal root is the non-negative root. So whenever there's a square root here and there's nothing, no sign in front of it, it's assumed to be the positive root. So you would just have 4. But on this one, it's asking for the negative square root of 16. Hence, you would answer negative 4. But then if it's asking for positive and negative, then you would include the positive and the negative. But now on a odd root, right here, that 3, it's always going to be whatever the sign is. There's not 2 solutions. So it's always going to be the sign that's in there, negative 5. Whenever there's an even root, it'll have a positive, negative solution, and you'll need to know which solution to provide, and this one's asking you for the negative. So you got negative 3. So negative 3 multiplied with itself 4 times would give you that 81. So now it's asking you to simplify some radicals, and you can do these. We've done square root of 8 a bunch. You can find a factor of 8 that is a perfect square, and then you can do this. But now some of the bigger ones, I don't know all of my perfect squares. So there's another method that I want to show you that's going to work easier, I think, for any type of root you're trying to find. So what I do is I make a factor tree. So 111 divided by 2, I said that wrong. 112 divided by 2 is 56. Divide that by 2, and what do we get? 28. Divide that by 2, and you get 14. Divide that by 2, and you get 7. So now I can group, since this is an index of 2, I can group these in 2s. I've got 2 of those, and I've got 2 of those. So you can do it a couple different ways. But what I usually do is I take 1 from each group, so 1 from each group outside the radical, and then the 7 goes underneath the radical. So 2 times 2 is 4, times the square root of 7 is the equivalent of the square root of 112. So if we had known that 16 was a factor of 112, then we could have done it that way. But I wasn't aware of that, right off the top of my head anyway. So now I want to apply this method to cube root. I could try to find a factor of 16 that is a perfect cube, or I can make a factor tree. So 16 is 2 and 8. 8 is 2 and 4. 4 is 2 and 2. And because I'm looking for a cube root, I'm going to group them in 3s. So I have 3 of those. They're all the same. So I'm going to rewrite this as 1 from the group, cube root of what didn't have a partner. So that 2 had to go back underneath the radical. So this is the same thing as saying 2 to the 3rd times 4 is 16. And if I'm trying to find the cube root of it, then I'm doing the cube root of 2 to the 3rd and the cube root of 4. And the cube root of something cubed cancels out, and I get 2 times the cube root of 4. Same answer that I got above. So if I were trying to do 162, again, I don't know my perfect cubes as well as I know my perfect squares. I'm just going to start making a factor tree. So 162 is divisible by 2. That's going to be 81. 81 is 9 times 9. Each of those is 3 times 3. So if I look for a group of 3, I have 3 of those. Then I can take 3 out front. Now this one and this one didn't have a partner, so they have to get multiplied back together and go underneath. And that would be my simplified radical. So keeping on with the same pattern. I don't know my perfect fourths, so I'm just going to start making a factor tree. I know that's divisible by 4. It's going to be 32, 4 and 8, 4 and 2, 2. So each one of those is 2, 2. Each one of those is 2, 2. So I'm looking for groups of 4. So there's a group of 4. And now I don't have another group of 4. So the ones that didn't make a group have to go back underneath the radical. So I have 1 from the group, and the cube root of 2 times, the fourth root of 2 times 2 times 2, which is 8. And then you can do the 6th root. Divisible by 4 is going to give you 32. Oh, I guess I've got the same factorization, don't I? 4, 8, 4, 2. Each one of those is 2. But in this case, I'm doing the 6th root, so I'm looking for a group of 6 things that are the same. So there's 6 2's, 2, 4, 6. So I'm going to take 1 from the group, goes outside the radical, and then the ones that didn't have a partner, didn't have a group to be in, has to go back underneath the radical.